Hello, grade 9 learners. My name is Thuto Masudubele, and welcome to our lesson on perimeter for today. Now, let's start with the definition of perimeter. Now, we can define perimeter as the continuous distance forming the boundary of a closed geometric figure. Or simply put, we can define perimeter as the distance around a shape. Now, it is calculated by adding the lengths of all the sides forming the boundary of the shape. Now let's look at the diagram given in the slide and calculate the perimeter of that particular diagram. Now what we notice is that we're dealing with a triangle and we're given the lengths of all three sides of that particular triangle. Now how will we calculate the perimeter of this triangle? Remember, the perimeter is the distance around the shape. So we add the distance around the shape, which will be 8 centimeters plus 14 centimeters plus 20 centimeters, and that will give us 42 centimeters. Now let's look at the next question. It says calculate the perimeter of the shape given below. What do we notice? We're dealing with a right angle triangle. So because we're dealing with a right angle triangle, and we're given two sides, where one of the sides is an unknown, I think by now you're aware that we're going to use the theorem of Pythagoras. But before we use the theorem of Pythagoras to calculate the unknown side, first need to get the lengths expressed in terms of the same unit. So the hypotenuse is given as 0.1 meters. We need to convert that to centimeters. And how many centimeters are there in a meter? We have 100. So we multiply 0.1 meter by 100, and that will give us 10 centimeters. Now that the hypotenuse is expressed in terms of centimeters, and AC is also expressed in terms of centimeters, we can use Pythagoras. So AB squared will be equal to AC squared plus BC squared. AB is 10 centimeters, AC is 6 centimeters, BC is still an unknown. 10 squared gives us 100, 6 squared gives us 36. Still don't know what BC is. We then need to also isolate for BC squared. So we add the additive inverse of 36 on both sides of the equation. And that will come out as 64. So we'll have 64 is equal to BC squared. Now how do we isolate for BC? We take the positive square root both sides, and the square root of 64 will then give us 8. So now we found the length of the unknown side, which was BC, as 8. Now we need to find the perimeter. And how do we find the perimeter? Perimeter is the distance around the shape. So we'll have 10 centimeters plus 8 centimeters plus 6 centimeters, and that will give us 24 centimeters. Now when it comes to circles, when you talk about the perimeter of a circle is called its circumference. So we don't refer to the distance around a circle as its perimeter, we refer to it as its circumference. Remember that, grade 9 learners. Now let's look at the basic parts of a circle that you need to be aware of. We have a diameter, which is a line segment that passes through the center of a circle from one point on the circumference to the other point on the circumference. So that's what we refer to as the diameter. Basically what the diameter does, divides your circle in half. And then we have a radius, which is a line segment that starts at the center and ends at the circumference. That's what we call a radius. Basically what a radius is half the diameter. So to find the circumference of a circle, grade 9 learners, we use an equation which is given as the circumference is equal to 2 times pi times the radius, or the circumference is equal to pi times the diameter. So when you look at the two equations over there, R stands for radius and the D stands for diameter. Now, given what we just discussed in the previous slide, let us now go ahead and find the circumference of the circle given below. Now, what do you notice that is given? We're given the diameter of the circle, and the diameter is given as 18 meters. So because we're given the diameter, we can use the equation of the circumference is equal to pi times that diameter. So pi times 18 meters will give us 18 pi meters. And then if you round this off to 2 decimal places, it will give us 56,55 meters. So that basically means that the distance or the circumference of the circle will be equal to 56,55. You can still use the other variation of the formula to find the circumference, which is given as 2 pi times the radius. Remember what the radius is. The radius is basically half the diameter. So if the diameter is 18 meters, the radius will be 9 meters. So we then substitute 9 in the place of the radius, and then we'll have 2 times pi times 9. That still gives us 18 pi meters, which still gives us 56,55 meters if rounded off to 2 decimal places. Now let's look at a little bit more complex diagrams. We basically call these diagrams composite shapes, where it's a combination of 2 or more shapes in one diagram. Now I want to find the perimeter of the diagram below. So if you analyze the diagram, we have more or less a rectangle and a semicircle or a half of a circle that has been cut into the rectangle. So then how are we going to find the perimeter, meaning the distance around the shape that is given to us? Well, the first thing we need to find the circumference of the semicircle that we see over here. And because it's a semicircle or half a circle, to find the circumference of that particular semicircle, basically use the same formula we used with a full circle, but we then multiply it by a half because we're dealing with half of a circle to find the circumference. So that will be half pi multiplied by the diameter. And what is the diameter? The diameter will be 6 kilometers because that will be the distance that passes through the center from one point on the circumference to the other point on the circumference. So that's 6 kilometers. So half pi multiplied by 6, that will give us 3 pi kilometers. And then if you round it off to 2 decimal places, it will give us 9,42 kilometers. So now we found the distance around this particular semicircle or the arc, the distance around the arc that we see over here. So that is now equal to 9,42 kilometers. Now that we have the distance around that arc that moves along that arc, we can now find the perimeter, grade 9 learners, because we know that the perimeter is the distance around the shape. So therefore, we'll have the 6 kilometers plus the 14 kilometers plus the 9,42 kilometers that we just found, distance along the arc of the semicircle, plus the 14 kilometers that's at the bottom of the shape there, since the top and the bottom lengths are equal, indicated by the symbols we see here. Then we add all of those lengths, and that will come out as 43,42 kilometers. Now let's look at the next composite shape, which is the last composite shape that we're looking at in this particular lesson. We want to find the perimeter of the diagram that is given below. Okay, so again, what do we notice? We notice we have a rectangle here, and what you notice here at the bottom, we have more or less a quarter of a circle. In the previous example, we dealt with half of a circle, a semicircle. So here we're dealing with a quarter of a circle. So we want to find the perimeter of this particular diagram. So again, because we're dealing with a quarter of a circle, we need to find the distance that goes along the arc of the quarter of a circle. Same formula that we used in the previous examples. We know that the circumference of a full circle is given as 2 pi r, But because we're dealing with a quarter of a circle, simply multiply the expression by a quarter. Now, what will be the radius of that quarter of a circle? The radius there already is given in the diagram. The radius will be 4 meters. So that is why we substituted 4 meters as the radius. Then we simplify the expression. We then get 2 pi meters. So that will be the distance that goes along the arc of the quarter of a circle. And if you round it off to 2 decimal places, that gives us 6,28 meters. So now we know the distance along the arc of that quarter of a circle. So now what are we left with? We need to find the length here that's at the bottom of this particular shape, where you see the pointer moving there. So how are you going to find that particular length? Since we know that the top length is 15 meters, and we know that the radius of the quarter of a circle is 4 meters, so all we need to do is to find the difference. So 15 meters minus the 4 meters, which is the radius of the quarter of the circle, will then give us 11 meters. So now that we have all of the dimensions of this particular composite shape, we can then find the perimeter. So the perimeter will be equal to 15 meters plus the 9 meters plus the 11 meters we just found plus the 4 meters that forms the radius of the quarter of the circle plus the 6,28 meters, which is the distance along the arc of the quarter of the circle, plus the 9 meters, which is the distance on the extreme left of this composite shape, and that will give us 54,28 meters. And with that, grade 9 learners, it brings us to the end of our lesson today. Please scan the QR code that will take you to a quiz that's on perimeter, and good luck.